Hi, my name is Sarah, and I wanted to make a video to talk about this SurfSub project that I have worked on. So this is a Python project which uses SQLalchemy to query a SQLite database to calculate statistical information about weather data in the database. So this project was really based on demonstrating analytical competencies, so being able to generate these summary statistics and kind of explain what they mean. So I wanted to make a video to kind of show the back end of things, to show how Python is working with SQLalchemy, and also demonstrate how Python and SQLalchemy can work with a simple Flask app to display information on an HTML page. So right now I am in the Jupyter Notebook app, just looking at the file structure. We have resources, which are just images that were generated by the challenge notebook I had. I have another Jupyter Notebook file. We'll take a look at this one. We have the Python file, which holds the Flask app, and then we have the SQLite file, which holds the data that we will be exploring. So taking a look at this first Jupyter Notebook here, we'll just touch on some of the dependencies. We'll kind of explain the setup for the SQLalchemy, and then we'll briefly kind of walk through some of this code and provide some context for the functions in the Flask app. So this project, we're using matplotlib. We want to create graphs, pandas, to create data frames, date time, to manipulate dates, and then of course the SQLalchemy to interact with the SQLite database. So next thing we're going to do is set up our SQLalchemy. So first thing we do is we create an engine object using this create engine function, which we imported up here. And we're just going to point to the location of the database file here. So next thing we're going to do is basically create a foundation for our code. We're going to use this automap base feature, which we also imported up here. And this just, like I said, it creates a foundation. So it basically allows us to transfer, it prepares our code to be able to transfer everything that's inside of the database into a different structure. So then we take that base object and we use this .prepare method. And this basically just, it reflects the tables of the schema. It creates classes to keep the data separated. So it basically decouples it, which you can kind of think of if you have like a box of extension cords, if they're all kind of knotted up together. If you reach in to grab one, you kind of pull all of them out. So this decoupling idea is that all of those extension cords have been like wrapped neatly. So when you reach into the box, you only grab the extension cord that you're looking for. So we can display the classes that this automap base feature found, and then we're going to save those references in their own variable. And then finally, we create this session object down here, again using this session that we imported up here. And this piece of code just basically allows us to query the data so that our Python code can basically talk to the database here. This is, I'm just kind of going through, I'll just kind of call out some of the things that we will see in the Flask app, and then just kind of like a heads up of how this kind of was structured. Is this was a pretty big learning opportunity for me. So you kind of see in this Jupyter Notebook file a lot of add-ons. So we start with a list, then we query the database, and then we add our parameters, and then we filter our parameters, and we put all of them into a list. So you can kind of see the steps that's in order here. So we'll just kind of go through this. I keep saying it. And we'll just go through it quickly. Yeah. So here we're using the date time to basically calculate. So if the date is today, this is the date. It's not, but if it was, we can calculate the date 1 year ago. So we do some calculations in the Flask app that deals with date time like that. And then I guess the next thing that I want to call out is that we use this session.query pretty frequently. So basically, that's just taking this object where we've abstracted this whole process of setting up SQLalchemy, and we're going to use it to query the database. So just kind of quickly walking through some of the things that we have done. We received the precipitation scores, we put them into a list, and then we use the pandas library to create a data frame and just kind of cleaned it up. So set the index equal to the dates and sorted the index by the dates and printed it as a string. So it just, looks nice and pretty. So we don't have to date twice. Using matplotlib, we do some graphing. Here is for the summary statistics, which were a big component of the challenge. Other things we can do, count the number of stations. And here's another thing that I would call out about the Flask app. So this code here, what we're doing is counting the number of occurrences of recorded temperatures for each station, and then we're going to sort them in descending order. So we find that this is the most active station, and we will see that again in the Flask app. Other things that we can do, we can calculate the minimum temperature, maximum temperature, average temperature. For this one, we just set for the most active station. Yeah, just a lot of querying. What the temperature, again, more graphing. So that's pretty much it. And I'll just quickly touch on the Jupyter Notebook for the README here. It's fairly simple. So we're doing the same thing, importing the dependencies, setting up the SQLalchemy to talk to the database. And then basically the whole project is we want to calculate the temperature statistics for June, which we did, and then the temperature statistics for December. And then we just kind of compare them and go through, and the idea is we want, like, what are the temperatures the best time of the year, and essentially the coldest time of the year, and hopefully that gives us some insights into whether or not people would want ice cream. So those are our Jupyter Notebook files. So we'll take a look at our app here. So I will call out that this file is called app.py. We'll see that in just a second when we open the Anaconda prompt to run the Flask app. So first we do the same thing. We do our imports. There are a couple of other dependencies that we are now using. We use NumPy to, in this case, basically ravel our data and create like a one-dimensional array, and we'll see that in a minute. And we also imported Flask and this JSONify feature, and I'll give kind of an example of what that is and shortly here. So then we go through the same process where we access the database. One thing to note here is there's an extra argument. This is just because I was running into an error, and that was basically my Anaconda prompted the reason why it failed. Objects created in the thread can only be used in that same thread. I plugged that into Stack Overflow, and this is the solution that I found. So this is the code that I got from that. So this Flask app. So first thing we do is we create an instance of the app. And then we kind of follow the same procedure for creating all of the routes. So first we create this root route here. And when we go to this route, we have this function which returns just a string of all of the other routes that we're going to have. So I have an anaconda prompt here. I've already navigated to my surfs up folder. So what I'm going to do is I'm going to say set flask app equal to app.py. And this is where the name of the file comes in. And then I'll say flask run. And we get this message here that tells us that it's working. So I'm going to take this address here and copy it. And I will just plug it in up here. And we can see, I'll just do this down. So this string that we have created, it shows up over here. And this is just, you know, it doesn't click or anything fancy like that. Again, this is just a really simple app. So yeah, that is our route. So for the rest of our routes, we kind of follow the same procedure. So we define our route. This time we are using the, I guess, like the file path that we're taking, basically. And then we do the same thing. We create a function to, you know, tell like the web page what we want to display. So we go through a route for precipitation, which displays the precipitation from the previous year. So again, this is where that date time comes in, just assuming this is the day. It's not, but based on the data that I got, that was, you know, the project. We're in 2017. It's great. Yeah. So down here, we are using this JSONify. So that basically just structures it like a JSON file. So if I want to go to this precipitation route, I can just copy this file path here and paste it up here. And we can see I have an extension here. It might look like this, you know, it's just like a dictionary of the dates and the temperature or the precipitation from that date, from that collection. So yeah, so we have a route for precipitation. We have a route for the stations, which just lists the stations here. Here's where we're using that NumPy again. Yeah, just to make, you know, a one-dimensional array. We have the temperature route. And again, we're using that date time to calculate, you know, 1 year back from this date. And again, here is the most active station. We pulled that up in that climate analysis Jupyter notebook. And then our last route here is a little bit different. So this route has a starting and an ending point. And we take in those, I guess, can't think of the word right now. Arguments, yes, in our function here. So basically, we want to be able to gather, let's see. So for a date range for the start and the end, we want to display the temperature minimum, the average, and the maximum. So we can use kind of this as an example where you can see, so if we enter this piece of code right here, you'll see it'll be null. And that's because, you know, we specified that we want the start and the end, and the arguments here are set like they're set to none. So you have to add something in here. This is just kind of like a placeholder. So if we add in these dates, you can see that we get the minimum, the maximum, and the average temperature for those dates. So yeah, pretty cool stuff. That's really it. And I just want to thank you for watching my video. I'll put a link to the code down below. And yeah, thank you for watching.